In many ways, the introduction of Lambda Expressions and Streams API have transformed the way we approach programming in Java. They made our code short, clean, and compact. Be it functional interfaces, lambdas, or method references. All these features of Java 8 have made it easier for us to create function objects. And Stream API helps in processing the data elements. So now since we have already discussed the fundamentals of these concepts, let's explore what are some of the best practices or best ways to use these features and how we can avoid using them unnecessary as well. Because it happens that when you become an expert in these approaches, you tend to put them here and there everywhere, whether they are needed there or not. And in that way, sometimes they lose their very purpose and goal itself. So, we will explore some of the best practices that are given in the book Effective Java 3rd edition by Joshua Bloch, where Joshua Bloch has perfectly explained the different scenarios in his book, and that gives a clear picture about the best use of these facilities. So, the first point is prefer lambdas to anonymous classes. Anonymous classes were adequate for the classic object oriented design patterns, particularly the strategy pattern. But since Java 8 has formalized the notion of functional interfaces, and that formalization of the functional interfaces allow us to create the object of those interfaces using the lambda expressions, or lambdas as we call them. So lambdas are similar in function to anonymous classes, but they are far more concise. But even when we are using the lambda expression instead of anonymous classes, there are certain things that we need to keep in mind. The first point is omit the types of all lambda parameters unless their presence makes your program clearer. One benefit of lambda expression is that the compiler deduces these types from the context using a process called type inference. Some cases the compiler won't be able to determine the types and then you have to specify them. So if the compiler generates an error that you specify the type of the lambda parameter, then you specify it. And if there is no need to specify the data type of a parameter inside a lambda expression, then you must omit that. There's no need to put a data type if it is not needed, because it's best to use the type inference facility provided by the language. The next point is unlike method and classes, lambda lack names and documentation. So Joshua said that if a computation is not self-explanatory or exceeds a few lines, don't put it in a lambda. Now you can ask how we will decide that how many lines should be there inside a lambda. On that, Joshua Bloch say that one line is ideal for a lambda, 3 lines is a reasonable maximum. But if you violate this rule, it can cause serious harm to the readability of your program. If a lambda is long or difficult to read, either find a way to simplify it or refactor your program to eliminate it. Because after all, what's the main purpose of lambda? To reduce the boilerplate code, to reduce the messy code of the anonymous classes. So if you have declared the same mess and the same length in your lambda expression, then it does not solve its very own purpose. Similarly, sometimes people think that now lambda expressions are here, so anonymous classes have become obsolete. Well, that is half truth, but not the complete truth. There are few things that you can do with the anonymous classes that you can't do with the lambdas. Like lambdas are limited to only the functional interfaces. But if you want to create an instance of an abstract class, you can do it with an anonymous class. And finally, lambda cannot obtain a reference to itself. In a lambda, the this keyword refers to the enclosing object, which is typically what you want. But in anonymous class, the this keyword refers to the anonymous class object. So if you need to access the function object from within its body, then you must use anomalous class. And the point to remember is that lambdas share with anomalous classes the property that you can't reliably serialize and deserialize them across implementations. So, therefore, in the book, Joshua Bloch say that you should rarely, if ever, serialize a lambda or an anonymous class object. So, lambdas are by far the best way to represent the function objects. Don't use anonymous classes for the function objects unless you have to create object of types that are not functional interfaces. Now let's talk about the next point, which is prefer method references to lambdas. Primary advantage of lambdas over anonymous classes is that they are more concise. But Java provides a way to generate function objects in an even more concise way than lambdas, and that is method references. Almost everything that you can do with a lambda expression, you can also do with the method references. So method references usually result in shorter, clearer code. They also give you an out if a lambda gets too long or complex. You can extract the code from the lambda into a new method and replace the lambda with a reference to that method. So method references provide a more succinct alternatives to lambda. Where method references are shorter and clearer, use them. Where they are not, stick with the lambdas. The next point is favor the use of standard functional interfaces. That means if there are already some standard functional interfaces available for your task, and there are many of them, then don't unnecessarily create a functional interface of your own. Use the standard ones that are available. This will make your life a lot more easier and your code will look cleaner and more readable. So if one of the standard function interfaces does the job, you should generally use it in preference to a purpose-built functional interface. There are 43 interfaces in java.util.function. You can't expect to remember them all, but if you remember the 6 basic interfaces, you can derive the most of them. So the point is, if one of the standard functional interfaces does the job, you should generally use it in preference to a purpose-built functional interface. So what are those 6 basic interfaces? The basic interfaces are those which operate on object reference type. Operator interfaces represent functions whose result and argument types are the same. Then we have the predicate interface. They represent a function that takes an argument and returns a boolean. We have function interfaces, which represent a function whose argument and return type differ. And we also have the supplier interface, which represent a function that takes a new argument and returns a value. And finally, we have consumer interface as well, which represent a function that takes an argument and returns nothing. So these are the 6 basic functional interfaces, and Joshua Bloch has summarized them in this table just to remember, just to keep them in mind. If you remember these 6 basic interfaces, you can derive the rest when you need them. The next point is don't be tempted to use basic functional interfaces with box primitive instead of primitive functional interfaces. So there are different variants of these standard interfaces that exist for primitive and for box type both. One must not be tempted to use the basic functional interface with a box primitive instead of primitive functional interfaces. The performance consequences of the box primitive for the bulk operation, for the large operation, can be serious. And finally, a practice that we should follow, and that's a very basic practice to follow, but that helps a lot. And that is always annotate your function interface with @functional interface annotation. This annotation is provided by the language to you to serve 3 purposes. It tells the reader that the interface is designed for lambdas. It's a functional interface. It keeps your code in a sync because interface won't compile unless it has exactly one abstract method. And it prevents maintainers from accidentally adding the abstract method to the interface as well. So putting add functional interface annotation before your functional interface is a good practice to follow. So these are some of the best practices that if we keep in mind, we can make best use of these features and we will continue using them for the purpose they are provided to us.